This second project in the 3-tier architecture series is called APIs with Lambda and API Gateway. We're going to learn to build a serverless API. This is so cool because APIs are used almost everywhere. Do you know what are APIs? Do you know how businesses are using it? Check it in the chat, and we're about to run through a definition of an API in this project too. Okay. In this project, you'll learn to build an API without having to manage traditional servers, say hello to AWS Lambda and Amazon API Gateway. This project is most ideal for roles like Backend Developer, Cloud Architect, Systems Engineer, where it's important to understand how to set up serverless architecture and manage your APIs. So in this project, we're going to have a lot of fun. We're going to develop a serverless Lambda function. Okay? And when that's done, we're going to configure an API with API Gateway. And this is the big thing here. Inside your API, you're going to need to connect your API with Lambda, and that's with the help of your resource and a get method. It's sounding a little technical. I totally get it, but it's totally okay because this is going to be super beginner friendly, and it's going to come with a lot of definitions, and we're going to do every single step together. Okay. Lastly, for the secret mission, you'll be writing some JSON documentation for your API as well. What this means is you can actually write documentation, not just like the project documentation we're doing for every single project, but API documentation too. It looks very, very different to project documentation. So that's why we're going to be exploring it a little bit in our secret mission, and you can do it all within the API Gateway console. Okay? So that's the last thing we're going to be doing as well in this project. Isn't that so exciting? I think APIs are one of those legendary things that just runs in the background so you don't really see it, but we absolutely benefit from it too. And it's such a big part of a web app because APIs are all about how different systems can talk to each other. For example, if you ever want to make a database, if you ever want to search something, okay, in maybe an e-commerce website or a website where you can buy something and you search boots. How is it that you get a page of boots as your search result? Usually it means that there was an API going on from your web app that connects your web app to a database of all of the products, and they quickly extrapolated boots. So they took all of the boots out from the database and put it in front of you in your web app. How the role that APIs play here is it is like the middleman or the person that communicates between you, the user, and also the actual backend logic, or in this case, the Lambda function that's running and creating all of this and doing all of this processing. In that boots example, what happened when you typed in boots and you pressed enter would have been that the API gateway or the API itself would have read that someone has submitted boots, they've pressed enter, grabbed your search term, the word boots, and then been the one to carry it over to Lambda and serve that word to Lambda and say, hey, we have this person that searched the word boots, can you go and process it for us? They want to just search for products, maybe with the word boots in it. Lambda does its job, returns all of the search results, and the API gateway is again the middle manager or the middleman that grabs all of those search results and displays it back onto your browser. So as you can see, API gateway just plays such a great role in order for us, the user, to interact with the application itself. That's the reason why API Gateway and Lambda make up the middle tier of our 3-layer cake for our 3-tier architecture. We've set up the presentation tier now, so there's going to be a nice, beautiful website that our user can interact with and click on. But what's actually going to happen when they click on a button? In our case, we have a website here. They can type something, they can even click get user data, but nothing's happening. Nothing's really happening right now because we don't really have a backend that's running any code based on what you've typed in, and you definitely still don't have an API set up to carry this data that you've typed in and give it to the Lambda function. This project is going to be about setting up those two those two pieces of our 3-tier architecture puzzle so you can have the logic tier sorted as well. Okay, so I hope that introduction was clear. If you have any questions, please let us know in the chat. And if you are coming into this project fresh and you're thinking, oh no, I did not set up the presentation tier, I haven't done the previous project in this series, and I haven't set up the website yet, don't worry. You can actually still do this project on its own, and you can still learn how to set up an API. It's more that setting up that website will be an important thing to do either before or after this project, so you have a full solution at the end of the series. Let's get started now and talk about what we're actually here to do today for step 1. Cool beans. In this project, we will demonstrate how to set up an API using AWS Lambda and Amazon API Gateway. That's the plan for today, team. How are we doing this? Why are we doing this? We're doing this project to learn how APIs work and also set up a snazzy logic tier in our 3-tier architecture. All right? And a big shout out to Viresh and After Office in the chat for saying hi. All right. So that's what we're here to do, team. So shall we get started? Your first step is to create a Lambda function. This function is going to fetch data from a database and return it to the user. So this is a very common use case in web apps where you have some data in a database and you need to fetch some of that data, give it to someone. For example, when a user searches for a product in an online shop, this is what we ran through with Boots. The website's backend needs to query their entire database of all the products in the shop, find the relevant products, and send all of those details back to the user's browser. So Lambda functions aren't actually the only way for you to do this. You can absolutely create your own micro services or small apps just to take care of the searching and how you will be retrieving data from a database and giving it to the user. Lambda functions are one of the many ways that you can do this, and we're picking Lambda functions because 1, it's serverless, so we don't need to manage any EC2 servers, and it's all around very, very quick and efficient to set up. So in this step, we're going to be creating that Lambda function. We're going to be setting up, configuring some of its settings so it matches our use case and why we're using Lambda today. And then we're going to be adding some code to retrieve user data that can retrieve user data using that function. Okay, so we are here. In this step, we will set up we also have Michael Agomo saying hello. Hi Michael, good to see you. How are you doing? Is this your first live with Nextwork? In this step, we will set up a Lambda function because this function will be the brains of our application, i.e. grab data from a database and display it to a user. Great stuff. Oh, it's your first live, Michael. Oh, good. This is so cool. Thank you and welcome. I hope you get cozy here. If you're new to Nextwork projects, I would love to recommend that you check out learn.nextwork.org to know more and to start doing projects with us. Or you could sit here, chill, vibe, ask questions, as many as you want. You're so welcome here, Michael. All right, to get started with creating that Lambda function, of course, we need to find Lambda inside the AWS Management Console. So we already have the console open, don't we? In this case, we're just going to be opening the Lambda console. You can see that it's here, but for everyone, if you don't know where to find it, you can always search for it. Click on Lambda. Looks good, everyone. And oopsies, I have a little function here that's already in use, but that's okay. Just make sure that wherever you are creating your Lambda function, make sure that it is in the same region as your bucket. Okay? Where's our bucket? Do you know? It was mentioned just now, actually. It was mentioned here in the name. It's in Oregon. Okay, so we're gonna go make sure our Lambda function is also in Oregon, and I'm gonna delete the existing one so we can start from scratch together. Great. So let's start from scratch and create a function from scratch. We're gonna select create function, and then for the function name, let us pick retrieve user data. Nice stuff. So we're gonna click on retrieve user data. Okay, and then we should be all good to create the function straight away. Before we do that, it's good to call out that you can actually select on changing the default execution role, and notice that we're gonna be creating a new role with basic Lambda permissions as we create this Lambda function itself. Interesting. There's going to be an execution role named retrieve user data, so on and so forth. Great. So two things we're technically creating here, a function and then its execution role. So let's break down what those two things are. What is Lambda? What is Lambda function in the first place? All right, so Lambda is a service that lets you run code without needing to manage any of the computers or the servers, because Lambda will manage those servers for you. That's why you will call Lambda a serverless service, not because no servers exist anymore, but more because you don't need to take care of those servers anymore. Lambda is going to take care of those servers. Lambda will only run your code when you need it to, and that is a great advantage of having a serverless service. It means that when you don't need to run code right now, you don't need to pay for any of those servers that are being managed. This is a big contrast to having to manage the servers yourself. Imagine if you have EC2 instances. You can't just say, oh, I'm not needing to run any code, so I shouldn't be paying for my EC2 instances. That's not really the case. For most EC2 instances that you use, you're usually paying in a more like committed fashion than only paying when the code is running. Okay, and another great thing about having a serverless service like Lambda is that it scales automatically. What that means is, if you have just a few requests a day, just a few people searching for boots, then Lambda can run the code when it needs to, and then those users will be happy. Now what happens if it's a Christmas sale and now lots of people are searching boots? Lambda will scale automatically, reacts to the demand, and now it can also serve all of those people that are searching for boots too. The key thing here is if you are managing all of those servers yourself, it will be on you to react on time and grow the number of servers you might be running or the capacity of your servers so that you can meet the increased demand. But Lambda is taking care of the servers for you, so you can actually be like sleeping at night. You don't need to be the one to change the settings for your servers. You can just relax and know that the increased traffic is being handled for you too. So that was a quick introduction to Lambda, and let's write down what we've learned. What is AWS Lambda? Do you think you can have a little quick definition of it now? Share yours in the chat, and I'm going to be writing one here too. AWS Lambda is a service that lets us run code without having to manage any servers ourselves. That's why it's called a serverless service, or function as a service. That's also one of its official names, actually, function as a service, because you are creating Lambda functions and code is being run in functions for you, and that is the main way that you're using Lambda. we're using Lambda in this project to the question, why are we using Lambda in this project? We are using it to run code that helps us retrieve data. And that is how it's going. That is what it's going to be doing in our 3-tier architecture. But Lambda's role can be different depending on what your web app is here to do. Would it be something like calculating a number for you? Could it be something like making something else change? For example, if you upload a file to your web app, maybe Lambda could be the one that grabs that file and uploads it to an S3 bucket in the back for you. So a lot of different things you can use Lambda for. Rohan's asking a real good question here. Would the serverless services be considered as PaaS, so platform as a service? Not quite, Rohan. So platform as a service is what you use to have a platform that gives you the tools to create your own applications. In this case, I don't believe that serverless or Lambda will be considered PaaS, probably because it doesn't really have a full suite of tools to be creating your own application. PaaS usually has more tools around the actual development of your code, any other tools or libraries you might want to bring into your development of that code. But I don't believe that those services or those features are being offered in Lambda. If Lambda does offer it, then I'm sure that it can be considered PaaS, where you can build your own application on top. Now the cool thing about Lambda is when you create a Lambda function and it does something for you, it can be considered an application on its own because it can take in inputs, it can create outputs, and that qualifies it as an application a lot of the time. Unfortunately, Rohan, I have a bit of a maybe kind of answer here, where I'm also unsure of whether Lambda has all of the full suite of features that qualifies it as PaaS. Because having said that, Lambda functions on their own can be considered like applications depending on what they can do. We might need to do a little bit more sleuthing or a little bit more researching to get to a full answer there, Rohan. But I hope some of my tips can help with helping you get to an answer there as well. And a big shout out to Kumar, Trilokya Kumar, for saying great. Thank you so much. All right, so now we know what Lambda is here to do, and we know that functions are like pieces of code that you run in AWS Lambda. So you write Lambda functions to do things like processing the data, respond to events. Think of Lambda as a service, functions as the actual code you're running. Okay, shall we get into continuing to set up that function? We have given it a name. We're going to keep the runtime as node.js, and the runtime is basically the environment that you're using to run the code. And then for the execution role, this is the second thing that we're creating here. The execution role defines the permissions of your function. Sometimes Lambda needs access to other services. Okay, if you want to upload a file into the S3 bucket using a function, you better hope your Lambda function has access to S3, otherwise that file's not going to get in that bucket. Okay, and that applies to all of the other things that you can use Lambda for. In our case, we're going to be using Lambda to grab some data from a database. So eventually it's going to be important that it has access to the database itself. How we're going to give the Lambda function access to things is through the execution role that it has. When we create a new role with basic Lambda permissions, what are those basic Lambda permissions? Those basic Lambda permissions are all just about being able to write logs. So the permission to write logs to CloudWatch. That's considered a basic permission because you're going to need logs in CloudWatch to troubleshoot any errors that Lambda might have. So for example, later on when you run a piece of code, imagine if that code doesn't work. There's some sort of syntax error or there's some sort of error. Lambda actually needs access to CloudWatch to even have the permission to write that error log. So we should definitely give it that basic permission. Otherwise, Lambda has no way to give us feedback on whether or not our code is working. Okay, so now that we know that we are giving it some basic permissions, cool beans. we can create the function and move on. Okay, so we have a few other tidbits here on different parts of the setup of a Lambda function. And if you were curious, might as well let's have a quick chat about it. Architecture is about the physical processor that is being used for running your function code. And the physical processor is not something you're managing, it's something that AWS Lambda is managing for you. But this is going to be the processor, the actual physical server somewhere in the world of AWS that's going to be running your code. So cool. I really love the way that so much physical manual work is being abstracted from you. But when you look at settings like architecture, you almost get reminded, oh yeah, at the end of the day, there is actually a physical server somewhere that's running this. It's just super convenient for me that I don't have to manage it myself. Okay, so let's create the function and then let's move on to adding the code. Great. So you can see that we've successfully created the function, and it's called retrieve user data. A pretty good hint on what the code is about to do. So you can now change its code and configuration. Let's do it now. Let's dive straight into the code and talk about how we can edit the code and give that function something to do. You might not see that error. That is an error you would get if you had a function with the same name. I don't think that would apply to you. If that error alarmed you just now when you saw it on my screen, just know that it's no big deal. You can accept it if you see it too, or if you don't see it, even better. Okay, but for our code, we can actually copy this code that's already been prepared for you and use it for this project today. No worries, we will still go through this code in detail so that you have full understanding of what we're actually doing. Let's copy this code that's given to us and put it in the code editor. Make sure you replace your region, this little placeholder here, with your actual AWS region. I am so guilty of always forgetting to replace the placeholders, which is so ironic because I'm also supposed to be the one that makes sure that everyone is replacing their placeholders. Okay, so once you copy it into your code source, make sure that you're just changing this now to your region's code, not Oregon, but US West 2. Okay, so for you, if you're based in, for example, Ohio, don't type in Ohio, type in US East 2. Okay, so match whatever region you're using, go to the right-hand side of it in your region list and note down whatever the code is for that region. So mine is going to be US West 2. All right, and then we're going to go straight into deploying it. Okay, and as you deploy it, you should be able to take a screenshot of your code and upload that into the project guide as well. So let's take a screenshot of our beautiful code and upload that into our project guide. All done. All right, so while that code is busy getting deployed, let's talk about what this code actually does. This code is called retrieving user data. This is our function's name. And just like the name, what this code sets up is a function that grabs data from a DynamoDB table. It will look for specific user data based on a user ID, and it returns that data with that user ID back to you. If there's an error, it also returns a lovely error message so you know what went wrong. We haven't actually set up the DynamoDB table or anything like user ID yet, and that's totally okay. That belongs to the next tier. We're in the logic tier right now of our 3-tier architecture, and the DynamoDB and all of that user data stuff belongs to the data tier, the last tier for this project. So no worries if you don't see that data yet. But let's at least understand the code a little bit better. This code is actually using Amazon SDK, which I think is super cool because I don't think we've actually used SDK before this. And from SDK, it's saying, can we grab or use DynamoDB today. I want to be using some DynamoDB functions in this code. And then in that using that DynamoDB kind of library or package, we are actually going to be querying what data matches this user ID. And this function here is basically where you break down a user ID that you input. Guess where? Yeah, the user ID you put in here. So the moment you type in your user ID, you click get user data, that triggers an event. And that event is like the biggest wake-up call for Lambda to be like, wake up! Something just happened. Go check it out. And Lambda's going to be like, oh my gosh, yeah, an event's just happened. Let me grab the data that's in this event and let me specifically extrapolate the user ID that's been submitted. And then, can I please pass that to the user data table in DynamoDB and say, hey, I have this key here, it's called user ID. I have this user ID here. Can you please give me the piece of data that matches that user ID? Okay, and over here you can see that you have some error handling as well. So if the data itself is not found, how should the application tell you that no user data was found for this ID that you've put in? There's also a bit of error handling around if you genuinely ran into an error, it will give you a different message. So oof, there's a bit of a problem. We've got an error here. Okay, all good things here. You've deployed a very practical piece of code, and you're now ready to explain what you've just learned over here. What does the code do? The code we added to our function will grab a user ID from a triggered event, which is submitting a user ID through a form or field in a website, and queries for a table, for a piece of data in DynamoDB that matches that user ID. The code also takes care of error handling. Thank you so much. Which is so good. All right. Ria says, late but made it. Hey everyone. Ria, it's so good to see you here. Oh my goodness. Fun fact, Ria and I actually caught up the other day, and I got to meet Ria for the first time. Such an awesome force of nature. I'm really excited for Ria to be here. Hey Ria, I hope you enjoy this project. We're in the second project of our 3-tier architecture series now, which means that this is what you will be working on right after you set up the website on CloudFront. You're actually still just on step 1 of this new project. You're not too late at all, and it's really good to see you. Cool. Okay, so we've deployed the function, and I don't think the pop-up is here anymore because it's been a while, but once you deploy it, there's no changes to deploy for us, but once you deploy it, you should be seeing a deployment successful little pop-up bar. We would have seen that at the bottom here when we first deployed it, but unfortunately I didn't scroll down enough for you to see that. But this is exactly what it should look like on your screen. It should match what in this screenshot too. All right? And great work if you see that. You've set up a Lambda function. So Lambda function tick. Like we mentioned before, a Lambda function is like the brains of an application. It is where you can set up the processing of code so that in our web app, Lambda is going to go and grab some data from a database. But how is our user activity in a website like this going to translate into something that Lambda's going to do? How do you connect those two dots? It's so fascinating to be meeting something like an API to learn how that connection happens. So now that we have our Lambda function ready, we need a way to access it. This is where the API gateway comes in. So what is an API? Oh my gosh, I love this concept. An API, or an application programming interface, is a way for different software systems to talk to each other. It's like a messenger that carries requests and responses between systems. In this project, what is an API going to be doing here? Our API is going to be carrying requests from your user's browser. When you're entering this, it's going to be carrying that request over to Lambda to give that request data to Lambda so Lambda can process it and then give the results back to you. So our API is going to be that runner, that middleman between you, the user, and the Lambda function that's supposed to be processing your requests. Okay, and let's explain what we're doing in this step. So in this step, we will be creating a new API in API gateway, because this will be the runner between the user's requests in their browser and the Lambda function that will process these requests. The API also returns the function's response back to the user. Yeah, so it plays a really big role here. Okay, I'm gonna just grab a quick second for you to ask any questions you might have about this, because the API is a big concept for this project. Let's make sure we feel comfortable about APIs before we I was gonna say move forward. Yeah, before we move forward. Alrighty everyone, now that we know we're here to set up an API with API Gateway, let's head to the API Gateway console. Here are some steps that are coming up for us. We're going to head to the API Gateway console. Ooh, and what is Amazon API Gateway? And then we're going to answer what it does. Okay, and then we're going to be creating a new API using the gateway. Okay, cool. Nice. And then we're going to configure the API by choosing a few settings. Okay, cool. And that leaves us with creating the API itself and setting it up. Okay, so that's what's coming up for us. And I hope you're also ready to be going through that API setup now. So we're going to head to the API Gateway console. And land at the gates of API Gateway. Let's see it. Oh wow. All right, we're here. Okay. This is an old API that's living in our account, but it might look like you have 0 APIs in yours, and that would be sweet. We can start with 0 APIs. We can always start with the home page like this. Oh, not this home page though. I was hoping for a different home page. That's okay. All right. Before we go into what is API Gateway, I see that Michael has a question here. What's the function we just wrote for the API? Oh, good question. Is the function we just wrote for the API. Now, the important thing to know here is that the API's role is that it's the runner between our user's activity or their requests, okay, over your web app. So it's the runner between this and your Lambda function. So no, the function we just wrote isn't for the API. The function we wrote is all about grabbing data from a database. But the API, and the reason why it's here, is because it's here to connect the user with the Lambda function. How can you, through this web app, tell the Lambda function that you're looking for some user data based on a user ID of 1? the moment you click on this, what's going to happen is that the API gateway is going to go grab this data and pass it to Lambda and almost be like the translator for Lambda as well. The function itself is doing something completely different. The function is going to receive the data from the API and then translate it into user data that the user is looking for. So it's gonna, the Lambda function we wrote is gonna process the data that it gets from the API and then gives the API the results of processing that information. I hope that clears it up, Michael. Is that a bit clearer about what the API and the Lambda function do? Okay, but we should be at the API Gateway console now, and let's create the API. All right, there are lots of different API types. It's not just one single API that's capable of connecting all of these different systems around the world. We're going to be doing a specific type of API today called a REST API. And look at that! It works with the following: HTTP, Lambda, AWS services. That sounds a bit like us, doesn't it? A REST API, which we're about to explore here, represents APIs that uses HTTP methods to interact with your resources. We're going to talk a little bit more about what this very technical definition means. You can always also use simplify to understand it better. A REST API is a way for different programs to talk to each other. It uses simple commands to send information back and forth. Okay, REST, compared to the other types of APIs here that you can see, is a very popular type of API, extremely popular type, because the way you can use REST is very flexible to any programming language. And for us today, we're going to be using that API to connect the user with the Lambda function. Pardon me, before we go down into the rabbit hole of creating that REST API, I see that I have actually skipped something here, and it's just about explaining what is Amazon API Gateway. What is the service that we're on right now? Okay, so Amazon API Gateway, it's an AWS service that makes it easy for you to create, to publish, maintain APIs. It manages incoming traffic, for example, directing them to the correct services, and making sure only the authorized requests can get through. So in our case, we have so much traffic that could come through from this web app. We could have so many people opening up the distributed website that we've created with CloudFront, have it open in front of them, and like spamming the button for getting user data. So API Gateway's superpower is that it can handle all of this incoming traffic and direct them to the correct service. What if you had 7 different buttons and each button connects to a different Lambda service? API Gateway is a great traffic manager to say, okay, you to this service, you to that service. It can read all of the traffic, the events that are happening, and take you to the right place. It's also great as almost like a security checkpoint because it makes sure only the authorized requests can come through. Imagine if only logged in users can click on a certain button. Imagine if only pro users can only use certain features. One thing that API Gateway can do is it can actually receive the events that are coming in, determine whether someone's actually authorized to do it, and then send their request to the right Lambda function if it turns out that they are authorized to do it. If they're not authorized to do it, the API Gateway is where you block that request and say, oh, sorry, can't do that for you. Otherwise, the Lambda function itself doesn't really have the capability to determine whether or not something is authorized. So you can see why API Gateway is so important. It's almost like this traffic manager and security bouncer for your Lambda function. And that's, the reason why we call it like the front door to a Lambda function. Okay, and for that reason, directly exposing Lambda functions to user requests, possible. You can actually do it, but it's just simply not best practice because it just doesn't have that built-in security or management features. Okay, great stuff. Amazon API Gateway is an AWS service that helps developers with creating, maintaining, and monitoring APIs. We're using API Gateway in this project to, what are we using API Gateway in this project to? Do you remember? We're using API Gateway in this project to connect our user with our Lambda function, i.e. the serverless backend for our web app. All good? And then we'll click next. Charge ahead for the next question. How do Lambda and API Gateway actually work together? When a user makes a request, i.e. submits a get user data, or we can say if they click on a get user data button, API Gateway's role is to receive the traffic, determine whether or not it's authorized, and pass it through to Lambda if it is. In scenarios, API Gateway is also a traffic manager it's also a traffic manager for requests. Cool? I hope that makes it a bit clearer on why we're using API Gateway. Okay, back to where we were with the REST API. We're now ready to click on build, and we're now ready to also answer what are APIs in the first place. APIs are tools that enable communication between systems. There are different types of APIs, that's true, like REST APIs, or can you see the other types? We have HTTP API, WebSocket API, and a REST API private. Oh, interesting. Create a REST API that's only accessible within a VPC. That sounds pretty useful actually. But we can also mention HTTP and WebSocket. My API is based on my API is a REST API, which means it uses HTTP methods and is compatible with most programming languages. It's also compatible with Lambda. It was mentioned here that it works quite well with Lambda. That's awesome. Actually, all of these work well with Lambda, so that's a good thing. You can even see that HTTP API works great with HTTP backends. All right. Cool. Let us select build next to REST API, and let us start to set up our API. The name of our API. Ooh, what should we call our API? Let us call it User Request API, and for the endpoint type, we're gonna keep regional. Okay, this is interesting. What are endpoint types? Oh, you can go edge optimized or private. So regional APIs are deployed in your current AWS region. Great, that's a standard option. You can even do options that route requests to the nearest CloudFront, which we just learned, point of presence. Point of presence is another concept there. And private APIs are only accessible from VPCs. So different types of APIs to suit different levels of access or exposure. And here we go. For us, we want to choose regional because AWS endpoints are accessible within a specific AWS region, which is great for localized applications because it has low latencies for clients in that region. You can see that Edge Optimized is great for global applications or private for internal networks. We can just go for regional because we're not really creating a global application today, this application only needs to be within the region that's close to us because we're probably one of the only users that will be using it. So let's go for that. Okay, but you can always pick edge optimized. Although I would recommend just going into AWS free tier and checking whether or not it is free to pick the edge optimized type. And let's create our API. I hope we weren't supposed to, okay, thank goodness. I was like, were we supposed to take a screenshot just now? Nope, we're taking a screenshot here. So let's take a screenshot with our resources page. Heads up, by the way, this page we're gonna come back to a lot. A very helpful page for maintaining your API. So we're gonna be seeing this page definitely more than once. And let's upload that. Cool. So why are we gonna be using this page so much? Because it gives you a dashboard view of your API, and you're gonna be managing things like resources, methods, deployments, settings. It's truly the central hub for monitoring the API, and we'll be using it to create the resource and the method coming up now. Okay? All right, so here we are. We're gonna be creating that resource like we mentioned. Okay, see how there's a resources panel here? So this is what we're about to create. So resources are like different sections or pages of an API. They help you organize how your API is going to handle different kinds of requests. Because as you can imagine, an API is about how two different systems communicate with each other. But there are so many different things that they can communicate about. What if one system wants to communicate with lots of databases in another system? What if one system wants to read items in your database, but it also wants to create items, it also wants to delete items? Those are considered different kinds of requests or different kinds of things that you could do with an API. You can also think about how a resource could be like, oh, I want to do something with a certain department in this resource and also do something else in another department in this resource. And because of that, you will need to start to separate out what your API can do with the exact same system. I hope that's clear. If you have any questions about APIs, we can actually use a cheeky simplify, okay, to give it a go. For example, you might have a resource for users, you might have a resource for products, another resource for orders. Each resource has its own set of actions that you can perform on it: creating, reading, updating, or deleting data. These sets of actions are called methods, which we're going to be talking about later on. But resources are really about the different kinds of requests that can come through. And for us, our API is only going to be doing things related to user data. But imagine if you had an e-commerce site that also needs to handle search data if people want to search for products. That's when your API needs to organize different resources. So in this step, we're creating a new resource in our API. This new resource will help us to organize what we want to do. Will help us organize what we want our API to do. Great. Okay, so we're about to create a resource called users. Okay, and oh, here's another example of resources as well if you want to see it. An API for a messaging app could have separate resources for retrieving messages and retrieving user profiles. Again, that's two different realms of the same application, so you'd separate out what that API could do based on kind of the department that you're using or the section of the app that you're using. An API is made up of resources which are different sections or different parts of the same API. For example, an API could have different sections for retrieving user data versus retrieving messaging data versus retrieving product data in the same app. Okay, very cool. So for our resource name, we're going to enter users. And let us enter it here so we can see it visually too. Once we click on create resource, we're going to type in users like this. Interesting setup, isn't it? There's a resource path like a slash, and then there's a resource name like users. So what's going to happen here? The resource name is just used to refer to that resource, but the resource path is like a file path, except that resource path is more about how can we even access that resource and its capabilities in the first place. You're going to notice the resource path a lot later on when we actually use the API. We would put in the API's URL, and then we're going to say /users to say that we want to use that specific resource. Otherwise, you could change your API query to say /products to now be using the products resource. Okay, so lots of different things that your API can do, and you would use the resource to define, oh, out of the many things you can do, I want to do this with you. Okay, so let's create the resource and let's take a screenshot of it before we move on. Maybe something like this. And then let us click done. Great work. And we've created the resource. Okay, so you can select it, your user's resource. Okay, so you can select your resource. And just know that you're getting really close now to finishing the setup of your API. We only have 2 steps left in this project, which is awesome. Okay. Since a resource can be used for many different kinds of actions, we actually need to separate down a resource and break it down into different kinds of actions. So for example, you can say, I can use the user's resource to retrieve data, delete data, update data, create new data. All 4 of those are different methods, different things you can do with the same resource. So you can see how you have your API made up of different resources, and each resource is made up of different methods. Great. So let us set up that method now. And you can use a get method to get data, post method to create data, a put method to update, and a delete method to delete. It gets a bit technical. Don't worry, we're only going to be focusing on one method today, which is get. In this step, we will be creating a method in our /users resource. This is because you can perform many different actions in the same resource. So methods define exactly which actions are possible and how they will be carried out. Great. So here's a little question before we dive into it. How do you think we're going to be carrying out the get method? How might we actually use a get method and retrieve some user data? We've created something that's going to help us with doing that. What do you think that thing is? Cool. So here we are. We are back in our resource, and you can create a method now. So let's create a method, and the method type is going to be get, because we're going to be trying to retrieve some data. Okay, so once we mentioned that we're here to retrieve data, the integration type is a Lambda function. That's right. This is where we set up the connection between your Lambda function and the API gateway. So what is an integration type? We'll answer that in a second. An integration type are like backend services that can fulfill an API request. This setting determines how API gateway passes the request data to the backend. Here we're selecting Lambda function as our integration type. So what that means is we're now setting up the method to be a method where API gateway can directly call on your AWS Lambda function each time someone visits that endpoint. Okay, so I know this is a little technical to understand using theory, so that's why we have this hands-on project for you to see it in action. When you eventually deploy your API and make it, you can use that API's link, that URL, to go /users to visit that resource. But once you visit that resource, what is API Gateway going to do? How is it going to call and bring out AWS Lambda? It's going to know to do this because that's how you set it up in the method. You use your method to say, hey, by the way, when someone visits /users and they're here to retrieve data, please go call up the Lambda function and pass the events or the data that comes from this event to the Lambda function. So this is really the bridge that we're setting up here between your API and your Lambda function. Really cool. Now that we've set it up, just know that there are so many different integration types. So there are a lot of things that could be running in the background. Instead of a Lambda function, you could have another AWS service that connects to the API, an existing HTTP endpoint, VPC link, mock. These are things we haven't really interacted with before, but there are slightly more advanced ways that you can connect your user with a backend at the back of your app. Okay, in the meantime, we know that we are here to switch on Lambda proxy integration to as a part of wrapping up the creation of our Lambda function. Now, Lambda proxy integration, this concept is an extra for pros concept for this project, but it's no longer an extra for pros concept by the time you get to the finale of the series, okay? Because this is eventually going to play a big part in being able to tie together all three parts of your 3-tier architecture. So what is it in the first place? Lambda proxy integration, such a big word for such a small little button. Look at this little switch here. It's so tiny that Lambda proxy integration, like this text here, is already 3 or 4 times the length. But it has a very important meaning here. It's a setting that really simplifies the connection between API Gateway and Lambda. At the end of the day, different kinds of systems can be talking in different languages. Lambda can be talking in JavaScript. In this case, we've written our Lambda function using node.js. But what if API Gateway talks in a different language? What if API Gateway actually communicates in JSON or communicates in a language that's not compatible with your Lambda function? Something that usually happens is that when the user interacts with the website, the request, such as you entering something here and then pressing here, that's a request. You're now requesting for data. That request gets sent to API Gateway first. And this request is not just going to be a number. It's not just going to be like 1. The request can come in a really big JSON format that contains, you have a request from this IP address. The request is in a string. That string is this person might be in this region, or here's some random information about their browser. The request can have so much information packed inside that just the user ID you're querying is one of the many different pieces of information that's coming through. So API Gateway, actually every time this event comes to API Gateway, it has a massive task of needing to break down that request that's coming from the user and reformat it in a way that Lambda can actually understand. Once Lambda returns the response, once Lambda actually processes the request and has the results, has the output, API Gateway then needs to take the output from Lambda and reformat it back into a response that your client browser can actually understand. So again, this is the reason why API Gateway is so important. It becomes this middleman that does a bit of translating, it does a bit of security, bouncer work, it also handles lots of different kinds of traffic, all to make your Lambda function not be overwhelmed, be able to understand the user's data, and actually work efficiently. Lambda proxy integration is something that helps the API Gateway to no longer need to reformat that request anymore. So when you actually turn that on, API Gateway no longer does the translation job. It takes the request and all of its information and chucks it straight to Lambda actually. So the Lambda function itself will need to be written in a way that is capable of processing the request internally. So the way we've written up our Lambda function looks a little bit tricky, looks a little bit complex for a reason. It's because our Lambda function is actually a really smart one that can actually understand the events, the raw event, from our user and be able to break it down. It doesn't need the API Gateway to do that translation work. So because the Lambda function is so smart, you can actually turn on the Lambda proxy integration setting, okay, so that the entire event is sent straight to our Lambda function. And here's where you get to mention, oh yeah, the Lambda function we're using is the retrieve user data function. Mention that, and I think you're all done. You should be able to create your method. Okay, so we can take a screenshot of the console showing the get method configuration for our resource. I can just do something like this maybe. Okay, so I've uploaded it now, and we have a question from Rohan here asking the Lambda function we created at the start. Correct. This is going to be the Lambda function we created at the start that's going to be receiving the full event from the user. We created a get method that will connect the API gateway with our Lambda function. This means that when an end user makes a request with our API, e.g. we have api.com/resource/ with our API, maybe like this. Oh, we know our resource name is called user, so we'll just put that in. This means that when an end user makes a request with our API, knows to pass the event or the information to our Lambda function if it's a GET request. Great. I should say our API knows to pass the event to our Lambda function if the user is retrieving data. I think that's the easy, clear way to say it. Okay. We created a get method that will connect the API with our Lambda function. This means that when the end user tries to make a request with our API, basically says, hey API, I want to get some data. Here's my request. The API knows to pass that event pass the information in their request to our Lambda function because it can recognize that it's using the get method the user's trying to retrieve data. Here's a use case that you can do this. What if in our web app, we actually had the ability to say, not get user data, but type in something and delete user data. If we had something like delete user data in here, we'd need to set up a delete method to say, hey, if it turns out that the user is wanting to delete data, can we please link that to another Lambda function that's capable of deleting the data for us? Okay, and that's why methods are so important. It maps the user intention to the right Lambda function. Cool. Okay, so once we've created the method, that means we've actually just set up our API. All done. Very good job, team. Now we just need to deploy the API and see it in action. Deploying the API, what that means is it makes it accessible through a public endpoint, so your users can actually start to use it. It's like you publish a website, make it live. Make it so that end users can actually start using it. So in this step, what you're going to do is you're going to deploy your API to a new stage. What is a stage, you might wonder? We're actually going to talk about the definition of stage in just a second. In this step, we will deploy our API because that's how our API will become accessible to end users. Great work. And a quick midpoint check, everyone. How are you finding this project so far? Has it been a bit confusing? Do APIs make sense? Does the connection between API and Lambda make sense? Share what you're thinking in the chat so we can also talk a little bit more about anything that we want to clear up. All right, team. So let's click on deploying our API. Oh, we haven't even created the method. Once our method is created, we can deploy the API and we can select a stage. Interesting. So this is what we mean when we say, let's talk about what a stage means. We're going to be selecting new stage and we're going to give the stage name prod before we click deploy. And while that's deploying, let's talk about what the stage mean. A stage is basically a snapshot of your API and what it can do at a specific point in time. So you're basically pointing at your API, you go click, and this is exactly a version of your API that your live users can be using. API Gateway lets you deploy different versions of your API to different stages. You want to be doing this because that's how you can control who can access what version of your API and when. This is very helpful for developers because you can be working on some features and you can be working on some unreleased features that only you can have access to. You want to deploy it anyway so that you can at least test it in some sort of live environment. So because of that, you can set up a new stage for this. You can set up a development stage to develop your API or a testing stage specifically for testing your API and deploy it into those stages so that you can internally test a live version of your API without it affecting your live users. Your live users would usually be in a stage called production, and that production basically means it's live out there in the world, everyone can see it, everyone can use it and access it. In short, we call it prod. So prod stands for production, and usually I think people usually say, oh, dev is like the short form for the development stage or the development environment. Cool, I hope that was clear. And lucky for us, we have started deploying our API a bit sooner, which gives us a bit more time for the deployment to actually happen and us to see what it looks like in the wild. I created Great, I created the prod stage. Sadly for me, I just realized that our screenshot is actually about taking a screenshot of the deploy API panel. So we're gonna quickly click on deploy API one more time and just do this, or maybe new stage. I hope this works. And just put it like this so that we can at least have a screenshot going for the project. Okay, and let's explain what we've learned about stage. When you deploy an API, you deploy it to a specific stage, and a stage is a snapshot of your API at a specific point in time. I deployed to the production stage, aka prod, which is where there is live traffic I think I'm going to change my definition of stage actually. I'm going to say a stage is a snapshot of your API to manage different API versions. We deployed to the production stage, aka prod, which is where there's live traffic and users that can access it. Good stuff. So once we've deployed it, you are back in that stage page. Stage page. Just rhymes too perfectly. And this is where you can actually manage what your prod stage looks like in terms of what you want to track, any other settings that you want to manage about that stage itself, and the deployment history. So this is where you can track when was the last time you deployed your API to prod. Pretty cool. Now, what's going to be very interesting to us is that there is a special URL just for the prod stage. Okay, so you can see that there's this URL here. You can copy it and you can visit it. Okay, so this URL is a URL where you can find that version of the API. So for us, the invoke URL inside that prod page is where you can use the prod or the live version of your API. In real-world scenarios, this is the URL that developers will now use to put into their live application's code, so that you are using the live production version of the API. And this is where you will probably most definitely not put the development stage invoke URL and not put the testing stage invoke URL into the live application. Make sure users are only seeing what should be in production. So you would cherry pick the URL that you put into your application so that they're always using the prod version.
Hi guys! Hey Jess. Oh, you on a call? No, that's on the screen.
Awesome. With that set up, you can now actually just access that URL in a new tab on your browser. Let us go into a new tab on our browser and load it. Okay, team? You're gonna see, oopsie daisies for us, that prod URL isn't really taking us anywhere. It just gives us a little message that says missing authentication token. Ooh, interesting. Why is that? Why are we missing an authentication token? Do you have any suggestions, any ideas on why that might be? All right, so the reason that we're seeing this is because it's down to what your Lambda function does. Do you remember what your Lambda function does? Your Lambda function is here to retrieve data from a DynamoDB table. When you have no DynamoDB table that your function is connecting to, what's going to happen to your API? Is it going to actually return some interesting, important results? Unfortunately not. Your function's probably going to be pointing to an empty database table that doesn't really exist, and we don't really need it. So we don't really actually have results that we can return from this API, which is why you're actually seeing missing authentication token too. Yeah, authentication is a tricky word to see. Dave, in the chat, I noticed that you mentioned it needs permission. Yeah, perhaps before you can even notice that you are returning basically no important results or 0 results, what's happening here is the Lambda function simply doesn't have access to DynamoDB in the first place. We haven't actually given our Lambda function any permissions to DynamoDB. If you try to invoke, or if you try to run an SDK or a kind of function inside your code that references DynamoDB, maybe your code's just going to fail as well because you don't have permissions to use that service. So a really good shout there, Dave. Really good point. All right. So with that done, let us mention what we've learned and get ready to slowly wrap up this project. So you'll get an error because we haven't set up our DynamoDB table yet, and that's okay. The API setup is all done, so you've learned how to create a serverless API. How cool is that? You'll get to actually create the DynamoDB table and connect it with the API in the next project of the series. Let's mention that here. To visit our API, what do? We visited the invoke URL for the prod stage, or the prod, or you can say for the API that is in production. The API displayed an error because the API is connected to a Lambda function that doesn't have permissions to DynamoDB, which might trigger an authentication issue. And it's also not connected to a DynamoDB table in the first place. That table doesn't exist. I don't have any characters left to mention that. Let's see if we can make our answer more concise. To visit our API, we visited its invoke URL. We visited the prod API's invoke URL. The API displayed an error because the API is connected to a Lambda function that doesn't have permissions to DynamoDB, which might trigger authentication issues. Also, no DynamoDB table even exists yet, so we probably need to fix that. Great, all done. So that is our project all wrapped up for the second part on creating your own API with Lambda and API Gateway. Great work. Now you can wrap it up here, write that final validation before you complete the project. But since this is our very first time working on this project, I think we should absolutely work on the secret mission too. And the secret mission is really cool. It's about writing documentation for the API itself. Every single project you do, you've been learning how to write documentation for your project. But what about documentation just for an API? Not someone that wants to read what project you've done, but someone that just wants to understand what does your API do. How can you write documentation for it? So in this secret mission, should you choose to accept it, we're going to be writing some documentation for the API, and there's a feature in API Gateway that helps us with doing that. Okay, the documentation we're going to write is going to be in JSON, and then in API Gateway, you can even publish and download that documentation too. Shall we jump in, team? Are we ready to go in? I'm pretty ready. Let's do it. Woo, we're in. All right, so that is our secret mission unlocked. We're committed now. I think we're committed now. We got to do it, team. In this secret mission, we will write documentation for the API itself. This is because API documentation helps other developers to understand the purpose and use cases of our API. Okay, so in the real world, how are you going to understand someone else's API and what it does for you and how you can use it? You really need to write out some great API documentation so that people understand it and that it actually gets used. All right, so let's get into it. Oh, actually, before I move on, it's also good to mention the importance of having this. Why is it important to have API documentation? At the end of the day, don't forget what APIs are here to do. It's here to help us with communicating between two different systems. So in the real world, a lot of developers can make some parts or some features of their app public to the world in the form of an API. Spotify has an API. A lot of news channels or forums have APIs, and those APIs can help you with extracting their database and the products that's in their database, the features that's in their database, information that you can access. So the reason why documentation becomes important here is imagine if Spotify had an amazing API that other developers could use, but they have zero documentation on it. You don't even know what URL to use, you don't know how to integrate it into your application, you don't know what kind of methods or resources are available. Just, oh yeah, we have an API, use it. It's going to be really difficult for you to actually make the most out of something that's incredible, something that's so useful. So that's also a reason why we should be writing great documentation for our own APIs, so that when we eventually create APIs that other people can use, that they actually go and use it, so it doesn't turn into unused or like wasted efforts. All right, so let's dive into this now and find the documentation tab for your API. It's in the console under the API section here. Okay, you're gonna need to find the documentation tab. Nice. Oh yeah, there's even subtitles that backs me up. I wasn't just saying random things, it's true. Add documentation to help developers understand how to interact with your API. Okay, an API gateway can store your content so you can create different versions of your documentation. Oh, you can also import documentation. Okay, if you've written it somewhere else and you want to just add it to your API as well. Thanks, Ria, for adding that. It's so important. Right? Thank you, Ria. Do you have a personal experience with documentation or APIs yourself? Really appreciate it. All right, team. So how are we going to be using this? We're going to be using this by going down and explaining why we're writing documentation first. Okay, before we talk about how we actually do that. For our project's extension, we are writing API documentation. For our project's extension, we are writing documentation because it is crucial for other developers to know how to use our API. Otherwise, if developers didn't have instructions, our API might not get used at all. You can write, one second, just had a quick thought. You can write documentation in the API. Have I run out of characters? Oh my goodness. All right, for our project's extension, we are writing API documentation because it's crucial for other developers to know how to use it. Or we can say we are writing API documentation so other developers know how to use our API. Otherwise, our API might not get used. You can write documentation in the API gateway console. Made it. And Ria mentions, I am the main person who works with technical documentation. Ooh. I am the main person who works with technical documentation for my team and projects. Projects do not always get worked on right away, so it's important to have so anyone can pick up the work. Very true. Very true. How will your API live on in situations where you might be away, you might stop working on it, but other people still want to use it? My goodness, goes a long way. So to create our documentation, it is quite nice and simple in the API Gateway console. You simply have to click Create Documentation Part, and you can say what your documentation type is. Are you writing your documentation for the entire API? Do you just want to select a specific resource you're writing this documentation for? A specific method within that resource? A very nice and visual way to organize your documentation, and the API Gateway can collate it all for you. For us, let's stick with something nice and easy and general, and just write on documentation about the API itself. So, in the code window, let's enter 2 simple lines to kick off our documentation. So we can kick it off like this. Here's a description that you can use. The user request API manages user data retrieval and manipulation. It supports operations to retrieve user details based on unique identifiers. I think this is a pretty generic, easy start. I think what we can do is we can actually edit this and make it our own a little bit. So the user API manages user data retrieval or user data requests. It supports operations to get user details based on unique user identifiers, i.e. user ID. The base URL, this is a placeholder that we have here for you. Is your API's base URL the same? No, it's not. It's not going to be, okay? Your base URL is something that you can find either in your API Gateway console or in the link that you've already opened for your invoke URL. So for example, where I can find mine is I can go back into my console and go back to where I found my prod invoke URL. So I can click into stage. Look at this beauty over here. It has the exact URL that points to my API. In fact, I can even copy it here and paste it so you can visit the site yourself, and you'll see that you have access, except that it just doesn't do anything right now because we don't have a DynamoDB table. So I've put it in the chat if anyone just wants to play around with the URL and see how it looks. But I can replace that placeholder with the actual base URL for my document, for my API. So we can create the documentation right away. Google's comments, oh man, hello, just got off work. How are you feeling? How was work today? I hope it still gives you enough energy left for doing some projects together. Thanks for jumping on. Work is a big thing in your day, I'm sure. To still come here, say hi, it means a lot, Googles. Very nice to meet you. Okay. So now that we've put in a bit of our JSON documentation in here, let's talk about what this documentation actually says. All it does is it gives you a high-level overview. So now a developer that's opening your documentation will say, oh, so that's what your API does. Gotcha. And then it also gives them the base URL. So helpful. Oh, this is a link I will go to play with your API. Gotcha. Great. Cool. So once you're there, take a screenshot of your JSON documentation and we'll add that to our project documentation. Okay, so let's add it in here and click done. Click create documentation part, not just done. Okay. So we've just created some documentation for our API, and now we can explore how you can actually use that. Once you've created it, so what? Okay, next is publish your documentation. Publishing it is like exporting your work in a special little file type, and then that special little file type you can upload into awesome tools on the internet like Swagger UI or Redoc, who will then read your file and turn it into a really nice web page that makes reading your documentation nice and easy. Because it's probably not very human friendly or like user friendly to read documentation that looks like this. You can even click on this link, like Swagger UI for example, to see how it actually turns it into a nice beautiful like interface. Okay, so that's an example. Swagger UI is awesome. You can also look at using Redoc. Everything API docs should be. Redoc is so beautiful, the way it turns your API documentation into literally like a web page like this. And all it does is it reads your file that you export from API Gateway, for example. Awesome. And here, once you are ready to publish your documentation, you will publish it to prod, and you can put in a version, like 1. And yet you publish to a specific stage. Isn't that so cool? You get to publish to a specific stage because that will give you the flexibility of writing different documentation for different stages. What if you have so many more features in the development stage that needs to have documentation around it? Then you should write that documentation, but don't put it into prod. What if live developers get confused? They're like, what? Your API can do that? Just publish that documentation to development so you and anyone that needs access to it can see it, but you're not exposing it to everyone. So it's really cool that you can also publish to different stages. I think that's an awesome feature. Once it's done, you can click on download documentation. And now here you go. Here are the different API specification types that you can export in. Swagger, of course, works well with Swagger UI. Okay, turn it into something like this if you upload it here. You can also use OpenAPI 3, and that works really great with Redoc. What if you can turn your API documentation into a web page like this once you upload it here after you export it as OpenAPI 3. But yeah, once you're done, you can just click publish. One second. I see. Very nice. Once you click publish, let us write a little bit about what we've just done. Once I prepared my documentation, I can publish it. I can publish it to the prod stage. You have to publish your API to a specific stage because different stages have different versions of the same API. So different explanations or requirements would be handy. Okay, really nice. Yeah, when we were publishing the documentation, you might have noticed that you had the Swagger type or the OpenAPI type, and these two are just two very similar actually formats for describing the same API, and different formats matches to different kinds of tools that can process these. It's like how when you export something, you can export in a Word doc so you can open it with Word doc later, open it with Microsoft Word later. You can download it as a PDF because you have a PDF viewer that you want to open it with. It's like the exact same concept with API specification types. But in our case, I just realized we exported our API, but I forgot to click on the export with API Gateway extension. So please click on this extension and you'll notice that this extension lets you see additional API settings that are specific to API Gateway. It's just like the documentation that we've written in JSON just now. That's considered like a additional setting that API Gateway has given us. So we actually need to export with those extensions. Otherwise, we can't see the documentation we've written. So make sure you export your API in that way. And then click Export API. All done. All right, so this is where you can actually open. Whoa, interesting. All right, this is where you can actually open the file that you've downloaded. And here you are. Isn't it so heavy what documentation looks like for an API? This is a lot to take in probably if you're new to API documentation. But yet just API Gateway alone can automatically generate all this interesting stuff for you. And this is the part where we've manually written things. So we wrote documentation, it was version 1. The type of documentation we've written it for, it wasn't for a resource, it wasn't for a method, it was for the entire API. And we wrote these two things, yeah? So that's how it ends up getting stuck to the end of our API Gateway documentation. The other text in this file are documentation that API Gateway has generated for you. And the main difference between the automatically generated stuff and the stuff that you can write is just the level of customization and specificity in each section. In your written documentation, you can custom write whatever you want to address, whatever you want the developers to know about, but the things that API Gateway can generate is the standard stuff across all the different APIs. So let's just take a screenshot of our documentation before we wrap up this secret mission too. Nice work. And we have Google's in the chat saying, tired, we'll have to start from the beginning tomorrow. Totally lost right now. Thanks for asking. Oh man, totally understandable if you just came here from a day of work. I'll see you tomorrow then, when you start from the beginning. And thanks for being here. It's awesome. All right. So our published and downloaded documentation showed us both our manually written and some automatically generated documentation from API Gateway. We can use this. We can upload this into tools like Swagger or Redoc to generate beautiful web pages about our API. Great stuff. Nice work. You've just learned how to write and publish your own API documentation. So we're ready to actually delete our resources and wrap up for this project. Now I'm not actually going to delete mine because we're keeping it for the next part of the series, but it becomes pretty simple for this one. First, we delete the API and API Gateway, and then you delete your Lambda function. In terms of your local computer files, you can also consider deleting some of the downloaded documentation you've generated in the secret mission. Okay, so here are some details on how to delete both resources, and then you'll land here in the final validation of this project. Services we used for this project were, what services did we use? Do you remember? We used Amazon API Gateway and AWS Lambda. Key concepts we learned include Lambda functions, definitely, API resources and methods, Lambda proxy integration. Such a big word, my goodness. Writing API documentation. Anything else we've learned today, team? Looking around here, I think, stages in your API. API stages are pretty good. What else have we learned? Deploying Lambda functions is a good one. The fact that we had the architecture, we even talked about this. That's pretty good. Oh, maybe invoke URL? We've learned so many new things today. Oh my goodness. I would say maybe an invoke URL. Invoke URL for an API. And as a reminder, the invoke URL is the URL that you would visit to see a specific version of an API, which is awesome. Man, all these learnings in one project. I'm really glad we got to do it together, team. And thank you, Michael, for the heart hands. Awesome. Nice work. This project took us approximately, how long did it take us? Again, I forgot to keep time. I think it took us approximately 1.5 hours, including demo time, including demo and secret mission time. The most challenging part was, what was the most challenging part for you today? Would you say, what would be a challenging part? Would you say the Lambda function code was quite challenging? I would say so. Yeah, let's say that was it. The most challenging part was understanding and writing the Lambda function code. It was most rewarding, though, to create the resources and methods. Personally, this is something that really helped me understand how you structure an API. Super informative about the API structure. So why do we do this project today? Did this project meet our goals? Oh wow. We did this project to learn how to set up the logic tier of a web app, i.e. how code is run, or actually, i.e. the backend, or the brains of our web app. This project definitely met our goals, and we learned lots about how an API works along the way. I really enjoyed learning about an API. The more you look into APIs, the more you realize just how much it's being used in the world and how many APIs are available in the world. I wonder how many APIs are available in the world, actually, now that I say it out loud. Alright, team. So that was a wrap on the second project of our 3-tier architecture series. 2 projects down in 3 hours. Not too bad. Not too bad at all. And I have to say, this project, the API project, is probably the harder one of the hardest ones. I think maybe the hardest would still be the last one, where you're trying to tie together everything. But this one is the more technical one, where you really need to understand the user, API, Lambda, and how it just connects together. But yeah, today you've learned how to create and configure a Lambda function. I love that it's a I love that the emoji is a lamb, by the way. I don't know if anyone else picked up on that. You set up and configured an API gateway. You created some resources and methods inside your API. This was so fun. It really taught you how a big API can be divided into different resources, like different things it can do. And within those different resources, specific actions you can take. And yeah, you deployed your API to a live stage. Bit of a bummer that you can't really see things right now, but that's the reason why the next two projects exist, okay? So we can tie together everything. Okay, everyone, I can see that we still have that pesky still task to complete. And when you see that, no need to panic, team. Usually, there's a reason for it. Aha! Then we found our reason. I still have 2 tasks that are not completed yet. Although it says I have completed it here. Oh, I missed the whole validation here though. That's definitely on me. Okay. Oh, and sorry, I noticed I mentioned the word validation, but what I was really referring to is just the different kinds of boxes of questions and screenshot uploads that you can click done for in a project. All right, so each resource consists of methods. Can you remember how to define a method? Methods are specific actions you can take within the resource in an API. For REST APIs, which is the API type that we're using, methods are based off of HTTP methods, i.e. get to retrieve data. There is also post to create data, put to edit data, so on and delete. Okay, so I think we can use that. Is there anything I've missed? I think that pretty much covers the definition of a method for this project. Yeah, you can say actions you can perform on a resource, so we can put that in here as well. Small changes. I think we're just ready to click done though. I think we finished everything pretty well. And DevOps methodology is here. Hi, DevOps methodology. I hope you're having a good day. Really appreciate your good vibes. It's awesome to be in a live with you, and you're so welcome here. Hello. How's your day? All right, team. We've, I think, finished all of the questions now, so we can click mission accomplished. Woo! Congratulations. 2 projects down, just 2 to go before we're done with the whole series. So, as always, you can share on LinkedIn. Let's do it. And you can post and be extremely proud of the amazing work you've done. What I'm going to do is I'm going to add this to my portfolio in NextWork. If you do post, by the way, make sure that you change this text from @NextWork to an actual tag, and that you upload your documentation like this as a document. Like this, for example. But for me, let's make sure I actually click on download documentation here. And perfect, let us add this to my portfolio. Okay. There we go. Thanks, DevOps, saying just awesome. Your vibes matching with high energy. Always, especially when you guys are here. All right, let's add to our 12-hour marathon project portfolio for the 3-tier architecture series. And let's add this project. Sometimes I forget what a project is called because you're so deep in the work. Like, what is this project called again? APIs with Lambda and API Gateway. That's the name. So we're going to upload the documentation as a PDF. Okay, do a little dance, sip a little bit of tea, and then upload your project. so good. I just realized I named the presentation tier in a specific way, and I want to vibe match that for my second project. So we're going to call this logic tier in our 3-tier architecture. Save our changes. Looking good. And here we go. Here's the documentation for our APIs with Lambda and API Gateway project. Wow, looking good. Services we used, our introduction to the project, Lambda functions, the Lambda function we created at the start. There was a whole API gateway we had to set up. That was pretty cool. Learning about how there are different types of APIs. API resources and methods. Oh yeah. And then deploying it to a specific stage. That was a good learning. And the secret mission, of course, gets some documentation time too. And we put it under API documentation. Doesn't it look so neat? I can't believe we did all this in an hour and a half. Sometimes I get so surprised myself. I'm like, whoa, we actually did that in an hour and a half. That's so cool. One great thing that I think I might show you now as well is that you can literally slide this back if you want to visit your project. But one thing that I wanted to show you was about editing your documentation. So this is a pro feature that I'm about to show you, but something that's really helpful is that as a pro user, you can actually edit your documentation and update the content inside. So you can update your documentation too. For example, you can go here and you can, over here, let's say we really liked the fact that we mentioned that we learned about different API types, and we want to add this in here in terms of key concepts we learned today. Then I can actually go here. As you can see, I unlocked the question, and I can even say key concepts we learned include Lambda functions, API types. Okay, click done, and again, click mission accomplished to generate the new version of your documentation that includes that updated answer. So yeah, that's a very helpful part of being a pro student that I thought I'd mention because I don't think I've showed that before. All right, team, we're about to go on another break. High five on getting 2 projects done. How did you find the API project? It is a little bit tricky. I think there are a few moving parts, but I hope this project made it seem a bit simpler, a little bit more approachable, a little bit more doable. You can absolutely create your own API with your own Lambda functions. Give it a go. You can even go online and see what other APIs are out there and think about, oh, how do you think we've created that? Was it a get method? Was it a delete operation? So many things you can look into. DevOps methodology says AWS Lambda is that one friend who only appears when there's a task, crushes it instantly, and then vanishes before you can even offer a high five. Honestly, yeah, that is a bit of a Lambda vibe. Shows up when you need it, just goes when you don't need it. It's like Batman. We're about to do a 3rd project. And this 3rd project is a treat. I love this one so much as well. If you thought Lambda was a bit tricky and you want to do a little bit more with Lambda, this project is gonna be that person for you. But this project is actually gonna be about the data tier. We're actually gonna introduce DynamoDB now, but there's gonna be a bit of Lambda work, and you're gonna see exactly why. We'll come back in 7 minutes in time for our next project.